Welcome to ICT1008 Punggol Map Development. We are here today to discuss on some of the prerequisites and dependencies needed and some of the algorithms and also time complexity before running some of the test cases. So from here, if you would like to know more information about our project, please visit our GitHub URL. And we are here to discuss some of the methods and libraries required to generate the graphs. So from here, we can see we import OSMNX. It's actually a library for generating graphs. As well as is moving on, if we look at this line, this is actually a line to generate a graph of location in Punggol coordinates with a distance with a radius of 3000. So the network type is drive service, which actually just indicate all the driving roads that belong in that radius and then be stored in a graph and it will be plotted out. So this is the outcome where you can see this is a driving graph. So if we change the network type to be a walk graph will be generated. So you can see actually the difference. And there you go, you can see actually this is a walk graph that is generated. So next we generate a nodes list and an edges list from the graph generator, and then we have to print out what is the value inside of it. So as you can see here is actually an array of dictionaries. So the worst case complexity of this is actually O of n, because in order to search for a node, the node could lie at the end of the array. So with that being said, we actually exported the file out and then stored it inside the various JSON files. And this is the edges where each unique vertices are represented by a unique ID. And then these are these adjacent nodes and distance in meters. These values are actually used as a cost for calculating Dijkstra later on. So on a side note, the time complexity of this adjacent list is O of D, where D represents the max degree of the vertice in the graph. This actually saves the space instead of adjacent matrix where you will take up space of ON square. And this is actually a nodes where we converted it to a double hash table. And as you can see here, this actually improved the time complexity to O1, where we can actually directly access the nodes inside the file. So moving on, we'll explain our code using the Django web framework to generate the graphs. So mainly you actually just have to see the views.py and the Dijkstra.py, and from here we actually commented. So by loading the Django web framework, this is actually a template of the HTML file. And so from here, let me walk through the codes with you. When loading the web page, all the files will actually be imported with its respective edges and nodes that will be used for calculation later on. And following which, this is actually a post web form. We actually receive input from users, the website, the web page, and then you will do its calculations right here, its respective calculations. And these are actually the abstract of the methods that are called inside post function. So as you can see here, we actually use Dijkstra and also A star. And the reason why we're actually using two of them is that for walk, drive, and LRT, we actually can use A-star algorithm so that for every node that we are traversing, the adjacent nodes, we can go towards the destination and not away from the destination. So this way we can actually improve the total cost by reducing the number of loops required to test all the vertices that's away from the destination. So moving on, we can actually see we have a Dijkstra for bus. So it's actually different from the A-star algorithm that is implemented for our walk, drive, and LRT. The reason being is that the importance for bus is actually the cost per transfer. The cost per transfer actually determines whether the path taken is the shortest path or the least transfer. Higher the cost per transfer, it's actually forcing the algorithm to always stay on the same path to reduce total cost. So with that being said, this Dijkstra only implements the minimum hit queue, which also will achieve time complexity of OV plus E log V, similar to our A-star algorithm. And moving up, we can actually see that we have these different abstract and functions for find nearest LRT, bus stop, addresses, convert to address, where you actually convert all IDs from dictionary to coordinates. So the complexity of find nearest LRT is actually O of n, because we have to loop the input coordinates with every single node in our LRT dictionary to see whether which one is the nearest LRT. And similarly for bus stop, we also have a time complexity of On, where you have to loop every single node in the bus stop dictionary in order to find what is the nearest bus stop. And then for convert to address, it actually converts an array of nodes into dictionary. So similarly, you'll have a worst case complexity of O of n. Here we'll be doing how to run the Django web framework. Here you can actually see the map is successfully loaded, and the map actually consists of icons for the LRTs and also each respective bus stops and its information. So from here you can see there's a choose starting point text box and a choose and destination text box. So how the user will use the map is just by clicking on any point of the map, a random coordinate will be generated. So by doing this, the user will then click on another spot on the map, and the destination will be automatically filled. So from there, the user can choose the mode of travel, such as driving, walking, train, and bus, before clicking on the search button, which will post a request back to its web server before returning with a reply. We will cover the driving mode of travel first, between these two coordinates. And there you go. And then secondly, we'll move on to the walking graph. So thirdly will be the train. So for example, the users decide to travel a little further near Cadalaw LRT. The user can enter the new endpoint here before clicking on the search button. Last but not least, we'll move on to bus. So by clicking on the mode of travel for bus, additional options will be prompted and available for the users. So the two options will be least transfer and shortest route. So in any case the user decide to click on least transfer, the cost for the transfer will be set to the maximum of 9,999. This to actually reduce the bus transfers and also force the DISRA to always stay on the same path. So as you can see here, the map is eventually loaded. So as you can see here, it's clearly indicated walk, bus, and walk. So of course the distance will actually be indicated and also the number of transfers, which will be 1. So now we will actually compare what's the difference between least transfer and shortest route. And as you can see here, the graph is loaded. So this is a shortest route on the same destination. As you can see here, it actually changes 2 bus before arriving at the destination. So the cost of transfer for the shortest route will be set to 0. So the actual distance will be the only cost that determine where the route of the bus will go from the source to destination. So from here, the limitation of our program is that since our nodes and edges are generated automatically by the OSMNX API, some of the zones in Punggol are not being covered. Therefore, it might reach a dead zone where a user will be unable to travel to that part of Punggol. So for that being said, the second limitation is that the calculating of route from the bus stop nearest to the source and the bus stop nearest to the destination will take approximately a few minutes due to the fact that the DISRA calculation from the source to destination expand in a outward manner by popping out the minimum cost from the heap queue until it reaches its destination. And therefore, due to the number of buses and the number of nodes in each bus route, the time taken to calculate the DISRA algorithm is multiplied. So last but not least, to end off, we have some improvements that can be made, such as converting the coordinates of the start and the end destination to readable form, such as addresses, to enhance user friendliness. And also, most importantly, for maps, we can use hierarchical graph so that when the user actually zoom out or zoom in, these are actually different graphs. So based on the distance that the user wants to travel, different graphs will be implemented and different routes will also be implemented. So this way, the algorithm will work faster for every distance that the user wants to travel. So to end off, you may visit our GitHub by clicking on this icon on the top left hand corner. Thank you.